subscribe to my channel and press bell icon for latest updates.
Hi, welcome to Learning Monkey. I am Raghuveer. In this class we will discuss about the coding part for support vector machine. In our previous classes we clearly discussed the mathematical part required for support vector machine, and in our previous classes we discussed the coding part which we discussed today is already discussed. Most of the coding part was clearly discussed at the naive base model for Amazon mobile dataset. Here we discuss the modification part. So what we modified here in this code for applying support vector machine, that part will be discussed here in this class. If you want to get the clear idea about the complete code, please watch our naive base Amazon mobile coding for Amazon mobile dataset. That video, in that video we clearly explained that, and most of the coding was clearly explained in our previous classes. So please follow our playlist for better understanding of the subject. The link for the playlist is provided in the description below. So to download this dataset and this coding file, the link to download this coding file and dataset is provided in the description below. So coming to support vector machine coding on Amazon mobile dataset, the first 5 blocks, this first 5 blocks of the code is on data preprocessing. We discussed this previously. So after data preprocessing we are taking, so coming here after data preprocessing we converted our data into Amazon mobile data cleaned.csv file. From that we are taking only 5000 data points. Why 5000 data points is support vector machine will take lot of time for execution. So depend on your system specifications, you can increase the number of data points. For understanding purpose and to make the executions fast, we are taking only 5000 data points. So we are taking 5000 data points. After we are converting this 5000 data points into bag of words, we applied bag of words. After that we apply support vector machine on our converted data. So how to apply support vector machine on our data set? Here in our previous classes, before going into the coding part, first we have to understand this. In our previous classes when we discussed the coding for logistic regression, we used the class called SGD, stochastic gradient descent classifier class. In this we discussed about loss function. Loss is equal to log, means if you place it as log, it works as a logistic regression. If you place it as loss is equal to hinge, means hinge loss. When we discussed about the soft margin support vector machine, we defined a loss function, that is we call it as hinge. Hinge loss means it works as support vector machine. So we can use SGD classifier for applying support vector machine, but the disadvantage with this is we can apply only linear support vector machine using SGD classifier. Linear means we cannot use kernel functions here using SGD classifier. There is a separate support vector machine class is designed for support vector machine, that is SVC. In this we can apply kernel functions also. See, look at this class SVC, sklearn.svm.svc. In this we are having c is equal to 1, default value is 1.0, and the kernel function is equal to default is RBF. We discussed about the C value and kernel functions in our previous classes. Hoping that you already watched those classes. We are not discussing what's the C value and what's the kernel function, all these things. C works exactly inversely proportional to lambda value, means if C is equal to 0, if C value is near to 0 means it works as underfitting. If C value is growing up means large C values works as overfitting. So coming to our support vector machine coding, we use SVC. So in this, see here, we used the class SVC. In this we are mentioning it as kernel is equal to linear. So different kernel functions which we can apply here is, check the kernel functions. The kernel functions, kernel is equal to linear means without any kernel function. Polynomial, RBF, like that we are having different kernel functions here. So we are not applying any kernel function here. Linear means no kernel function, and we are taking different C values. So we have to identify the best hyperparameter C value. At what hyperparameter value we are getting the best support vector machine is working best. That's the hyperparameter tuning we have to do. So we have to identify the best C value. For that we are using the Gridsearchcv. So this is the modification code which we have done here, and remaining all the code was almost similar, because that's why we are not dealing with the remaining code. We use Gridsearchcv for identifying the best C value. We used the ROC curves for identifying AUC plots for identifying the best C value. This is the plot which we got after applying support vector machine. The only difference which you have to identify here is at C is equal to 0, it's going to underfit. From as C value increases, it is moving towards overfitting. That's the one you have to understand. Okay, from this we will identify the best C value. At C is equal to 0.01, we got the best C value, best percentage value 86.6%. So we use C is equal to 0.01 for generating our support vector machine model. This C value is considered as the best C value. So now we use this best C value and we generate our support vector machine model on our dataset, Amazon mobile dataset, by taking kernel is equal to linear, C is equal to 0.01. But the only the disadvantage with support SVC is it's not a disadvantage. In SVC we don't have the probability values, but without probability values we cannot generate the AUC plots, area under curve plots. So how to get the probability values? For that we will use the function class called calibrated classifier CV class. This calibrated classifier CV class can generate the probability scores. So we are, for this calibrated classifier CV, we are sending our name, means our model. So it will generate the probability scores. How it will generate, what's the logic it will use, we will discuss this after completing all our models. For now, just remember calibrated classifier CV is used for generating the probability scores. So we use this and we'll generate the probability scores, and remaining all the code is similar, which we discussed in the naive base, how to generate the best threshold value, how to plot the AUC plots, how to plot the confusion matrix. All these things were clearly discussed in our previous classes. So for this, with this we will generate the confusion matrix, AUC plots. So this is our confusion matrix for training and testing data. We applied this support vector machine on dataset, Amazon mobile dataset, by converting our dataset into bag of words. In our KNN we discussed the coding part for how to convert into TF-IDF, average word to vec, and TF-IDF word to vec. You do it on your own. You take the code from KNN and generate the TF-IDF, average word to vec, and TF-IDF word to vec, and apply support vector machine on the datasets, on the converted TF-IDF datasets. Hope you understand the concept. If you have any questions regarding the concept, please post your questions in the comment section below. Thanks for watching. If you haven't subscribed to our channel, please subscribe to our channel and press bell icon for the latest